I'm a palynologist and therefore I study fossil pollen to reconstruct the vegetation in the past and to better understand the influence of climate on vegetation.
My name is Fabien Maussion and one of my axes of research is to try to understand how glaciers react to past and future climate change. And to do so, I'm developing a glacier model which is open source, so available to everybody, and which is able to simulate the dynamic response of glaciers to climate input.
Yeah. Hi, I'm a geologist and I'm interested in the history of Earth on timescales up to hundreds of thousands of years. Just think, I'm standing here in Obergurgl, and less than 20,000 years ago there was at least 900 meters of ice above us.
Okay, what I'm doing is to develop new statistical methods with the idea to improve the weather forecast so that we have a better forecast for tomorrow or a week in advance.
So I look at lake sediments, that's mud that is deposited in the lake, layer by layer, and there I look for remains and reconstruct past environmental conditions and climate conditions from these remains.
Hi, my name is Marc Luetscher. I'm a paleoclimatologist and cave scientist. I'm mainly interested in understanding how the climate signal from the outside atmosphere is transferred to the cave and what we can record in terms of long changes.
I'm working on a downscaling method which is to generate high-resolution climate data for the Austrian Alps, and this data will be having high resolution in space and time.
Yeah, basically I'm quite fascinated on all kinds of climatic processes and the interaction between climate and humans. Yeah, I'm working with lake sediments, and in particular I'm interested in flood events, and I try to reconstruct flood events by using lake sediments. So I'm identifying tiny layers of sediment deposited by flood events in the lake and try to reconstruct flood activity over the last few thousand years.
So hi, my name is Katee Wendt and I'm a PhD student here at the University of Innsbruck studying paleoclimatology, which is essentially the study of Earth's climate history. My research focuses on arid regions, so regions that experience frequent and extreme droughts. And what I do is use cave deposits to try and reconstruct some of the hydrologic and climatologic changes that those regions have experienced in the past.
So in my research I have two directions to go. First one is to find links between research topics, to make bridges visible and probably also to motivate people to try to get in the middle of the bridge and have the perspective from there.
So I am an atmospheric scientist, and the big challenge in atmospheric sciences today is to increase the knowledge about local scale atmospheric conditions, and together with many people I work on increasing this knowledge and decreasing the uncertainty. And this is particularly important in mountainous terrain like we have around Innsbruck.
Well, I'm studying all kinds of biomes in the past, especially in the Quaternary, so the last 2 million years, and I'm especially doing that using microfossils as pollen or fungal spores or algae cysts and all kinds of other microfossils, and also macrofossils from plants and animals, and with the aim of reconstructing past climate, and for the younger periods also to disentangle climate from anthropogenic impact.
For my research I use stalagmites that you find in caves and also flowstones. Flowstones are similar to stalagmites except that they form from very thin sheets of flowing water rather than drips of water. And the water that the stalagmites and the flowstones formed from has come from the oceans, travelled through the atmosphere, through the soil, and ended up in the cave and deposited these stalagmites and flowstones. And I then take these deposits, cut them open and analyse the chemical signature to understand how the climate has changed in the past.
My name is Meyer. We are focusing in our research on dating. We're using a technique that's known as luminescence dating, and this technique allows us to constrain the positional age of archaeological and geological sediments. And our ultimate goal is to better understand Earth surface processes as well as human environmental interlinkages of the recent geological past.
I do pollen analysis. That means that I collect and identify pollen from different terrestrial archives, like caves, glaciers or peat bogs. And studying pollen samples allows you to see what was happening in the past at different times within various landscapes. And therefore, pollen grains are a valuable proxy to study past climata.
I'm mainly working by means of tree-ring analysis on wood samples in different scientific research areas within the time window of the last about 10,000 years. So the research fields are from archaeology to Holocene, glacier and climate reconstructions.
My research is about atmospheric processes that are important for interpretation of ice cores from Antarctica. And these ice cores are used to derive information about the paleoclimate, like the temperature of past times. And this is very important for understanding the climate system.
Okay, I'm studying glaciers worldwide. And my most motivation, or the biggest motivation to study glaciers, is that they contain information about climate. It's not the other way around. That's easy to say I have a certain climate and the glacier does this and that. But the more challenging is I see a glacier behaving this or that way, and what does it tell me about climate and climate change, climate fluctuations? And in order to get the right environment, we went into tropical regions, tropical high mountains, where we study glaciers on Kilimanjaro, in the tropical Andes, on Mount Kenya, Ruwenzori and so on. And they have a very special way of telling us a lot of moisture changes in the circulation patterns. And recently we have come back to the Alps, where we think we have a better lab situation where we can study processes in a much better environment than in the altitudes of 6,000 meters and more.
Great, okay. So I'm a geographer and I'm an assistant professor at the Institute of Geography, and I'm working in the field of alpine hydroclimatology. So I'm interested in water fluxes in alpine catchments and how these possibly change under climate change conditions.
Hi, I'm a PhD student at the University of Innsbruck, and I do past climate reconstruction in a very dry alpine valley in northern Italy. I use speleothems, which are cave deposits, to reconstruct past climate changes. And if you go to this valley today, you can see that it is really dry, but if you look around, there is a lot of evidence, geomorphological evidence, that climate has been much wetter in the past. And I try to use these speleothem samples to understand when wetter climate happened and why it happened.